Hello, in this video we are going to start studying cosets. In particular, I'm going to try to motivate the concept by looking at geometry and the notion of parallel lines. Alright, so oftentimes the notion of coset is introduced by just giving the definition, which looks really weird at first because it's just defined set theoretically, and I often find students struggle with it. So here I'm going to start with the motivation, and then the definition, and then some examples. So to me, a coset is really just a generalization of the concept of parallel lines. So the motivation is, suppose you have a subgroup of H. H is a subgroup of G. You have X and G, and X is not in H. Okay, there's not much else you can say. Suppose you have another element that's not in H. Well, there's not much you can say. These two elements are in the out group, I guess you could say. The question you could ask, is there any way that X and Y are somehow still related? And to use an analogy, if G were the set of all students in a high school and H were the set of athletes, just because X and Y are not athletes doesn't mean that there isn't some other way in which X and Y might be related. So let's see if there's some other way to relate elements in a group that aren't in a subgroup. And here's my starting example. Let G be R squared, which we've seen is a group with respect to addition. That was one of our in-class assignments. Good job. Let H be the set of ordered pairs. The set of points where the X and Y coordinate, the first and second coordinate, are the same. I guess I should technically sketch out that this is in fact a subgroup. Take two elements in here. They must be of the form XX and YY. They have to have the same first and second coordinates. Well, by definition of addition, you add the first coordinates together, and you add the second coordinates together. Adding first coordinates, adding second coordinates. And we see that the first and second coordinates are the same. So the sum is also in H. Likewise, the negative of XX is negative x, negative x. So again, the first and second coordinate are the same. So H is a subgroup. In fact, actually, H is the line y equals x going through the origin. Well, let's look at my question again. Let's pick these two specific points. X equals 0, 2, y equals negative 3, negative 1. Note in this case, because G in this example is a set of ordered pairs, my examples should be ordered pairs. Are these two somehow still related? Well, yes, there's a straight line between them that is parallel to this one. They still lie on a line of the form y equals x plus something. In fact, y equals x plus 2, isn't it? If you plug in 0 for the first coordinate, you get 2 for the y coordinate. If you plug in negative 3, you get negative 1. So the point I was trying to make in this particular example is it could be the case that x and y are on a line that's parallel to H. So then we could try to make that concept more general. Maybe in an abstract group, with respect to a subgroup, x and y are related because they're on a line that's parallel to H. Whatever that means. So we need to explain what we mean by line. And the generalization of line is called a coset. So given a line through the origin and a point in R squared, you might remember from geometry that the line through x that's parallel to L is this line. It's all those points y, such that when you subtract x from it, you end up back on the original line you're interested in. So there's your origin, there's L. You got x over here. You're looking at any point y, such that when you do y minus x as vector subtraction, you end up with a point on L. That's something you can check. It ends up being true. Why is that true? Because what y minus x is telling you is the slope, or at least proportionally. If you're talking about y minus x, I mean, that's telling you the first coordinate is telling you how far in the horizontal direction you have to go to get from x to y, and the second coordinate is telling you how far you have to go in the vertical direction. And so, in order to be on this line, that ratio has to be the same ratio as on this line. They have to have the same slope. You can, of course, do a substitution here and say, well, instead of calling this point y, I'm going to say, so if y minus x has to be on L, it has to be the form little l for some little l. Which means I can move the x over, and I'm just looking at x plus L. So y is equal to x plus L, such that L is an L, and then I can get rid of the y entirely. And instead I can refer to my set this way. So looking at x plus L, where L is an element in my line. And so L prime is literally can be written this way. It's the set of all points of the form x plus little l, where little l was a point in my original line. That defines my parallel line. And so for a shorthand notation, rather than call this parallel line L prime, I'm going to call it little x plus capital L. Why? Because little x is a fixed point, and capital L is representing the idea that I'm going to add every element of L to x. And for each one, I'm going to get a different point. And this collection of points is this set. Turns out that's exactly what we do to define a coset. H is now a subgroup. X is an arbitrary element in G. Then the coset generated by X, this is like a parallel line, we call it X times capital H. It is a set, just like a parallel line is a set of points. It is a set of points. The points are all things of the form little x times little h, as h runs through the subgroup. So each point corresponds to a point in the subgroup, just like each point on this parallel line corresponds to a point on the original line, in the exact same way. Likewise, using the exact same substitution trick, you could also write it this way. They're all elements in G, such that when you multiply on the left by x inverse, you end up in H. Note this is slightly different because in groups we're not assuming commutativity, so order matters. So it's and we're working with multiplication instead of addition, so instead of subtraction I need inversion. And it turns out the correct order is multiplication on the left by x inverse. So that's it for right now for motivating the definition. This is the definition of a coset. It's just a set of points of this form. One way to think about it is just being a generalization of parallel lines.